Hi, we're Team Syzygy from Poolesville High School, Maryland. In 2020, 1 in 4 American adults were living with a disability. Of these 61 million people, only 17.9% were employed. Despite this low employment rate, the majority of working-aged adults with disabilities have said that they want to work. Employers also state that they want to hire employees with disabilities, but there are many challenges that are stopping them. These include a general lack of awareness about people with disabilities, limited accommodations to make work comfortable and efficient, and cost concerns. For the SourceAmerica Design competition, we created the bag operator to aid in the opening, filling, and closing of Ziploc-style bags. Ziploc-style bags are often used for packaging due to their low cost and convenience. However, these types of bags pose difficulties to people who aren't able to move in a full range of motion or with the same precision as other people. These are people with visual impairment, lower mental processing capabilities, a limb difference, and other disabilities which affect their movement. To ease the difficulties involved with opening, filling, and closing a Ziploc-style bag, we designed the bag operator. The bag operator is composed of 3 separate parts: an opening system, a filling system, and a closing system. Our initial approach with the opening system was to create a device that helps the user pull the tabs of the bag apart to make them easier to grab. The device consisted of 2 blocks attached to opposing rods with neoprene silicone pads adhered to the inside that stick to the sides of the bag and pull the tabs apart. The user can then grab the top of the bag and pull it open. However, this design still had limitations since the device still relied on the user's motor skills to pull open the bag, so we changed our approach. Instead of pulling the bag apart, we wanted to use the neoprene silicone to slide the bag open. Our new design took this idea to create a panini press-like device that sandwiches the Ziploc-style bag in between 2 neoprene silicone pads. The user then grabs the handle and slides the upper silicone pad. The tackiness of the neoprene silicone pads helps to grip the 2 sides of the bag and slide them apart. Once the user slides the handle, they open the device and remove the now open bag that is ready to be filled. Our initial filling system consisted of a cone mounted onto the backboard of our device. However, after making the adjustments to the opening system, we needed a way to prop the bag up under the filling system. So we repurposed our initial opening device design with the addition of a hand crank to support the bag under the filling system. After the user opens the bag with the opening device, they will stick one side of the open bag onto the inner faces of one of the blocks. Then they will use the hand crank to bring the blocks together to stick the silicone pads to the other side of the bag as well. Finally, they crank the blocks apart again until it is completely open underneath the funnel. Once the bag is open and centered, the user can slide the objects through the funnel and into the bag. When the bag is full, the user can easily unstick the bag from the neoprene silicone pads and bring it to the closing device. The first iteration of our closing device consisted of 2 cylinders placed next to each other on the bottom of our device. The 2 cylinders create a funnel-like shape that allows for the user to easily slide the bag in the gap. The sides of the bag will then be pressed together, which closes the bag. Our final design was very similar to this first iteration. Instead of having the cylinders connected to the rest of the device, we decided to make it a separate device altogether. To use the closing device, the user takes a filled plastic bag and aligns the top with the cylinders. Then they slide the bag through. In our testing, we were able to confirm that the funnel closing system and the threaded gear system worked as intended. We also proved that the neoprene silicone pads were capable of opening a Ziploc-style bag even without the rest of the device. Finally, we also determined that the neoprene silicone pads were able to hold up to a 5-pound load, meaning that the blocks on the filling system would be capable of supporting a bag, allowing for the user to have both hands free to fill it. To make our device cheap and easily repairable, we didn't use any mechanical parts. Additionally, all of the materials that we used can be bought at any hardware store or online. In the end, the total cost for all 3 components was just about $10. Since our device is composed of 3 separate devices, it is easily customizable to meet the needs of the person or company that is using the device. This makes it more cost-efficient and accessible since companies can purchase and use only the components that are necessary for them. Our device was designed to help people with disabilities that affect their motion operate Ziploc-style bags. All 3 components of our device are able to be used with one hand and utilize obvious and simple motions to complete their tasks. In the future, once it is safe to meet as a team again, we hope to properly build, test, and deploy our device. Our device gives an opportunity for people with disabilities to gain independence at home or in the workplace by giving them an easy-to-operate device to open, fill, and close Ziploc-style bags. We would like to thank SourceAmerica for leading the way towards a better world for people living with disabilities, and we would also like to thank Mr. Lee for guiding us throughout the entire process.